This is factoring expressions number 6. It's the last lesson of the unit, and we're diving deep into what looks like complicated problems, but it really is just another form of factoring trinomials. So I see an x minus 1 and x minus 1, and I'm going to replace that right now with, let's put a star. 10 star squared plus 13 star minus 3. Or you could put a big X there, whatever you prefer. I'm looking at this trinomial, and I see there's no number I can divide other than 1 out of all 3 terms. 10 times negative 3 is negative 30. I'm looking for 2 numbers that multiply to give you negative 30, combined to give you a 13. 1 and 30, no. 2 and 15, they do work. It needs to be a positive 15 and a negative 2. So down here, okay, look back here again. I maybe should have made this an x so it's not so confusing. Let me go back and make that an x. Really large x. So x minus 2 and x plus 15. Now notice that the exponent was a 2. When I divide it by 1, I just get x to the first and x to the first. Now the leading coefficient is not 1, so I need to put it on the bottom. And then I need to reduce each fraction. 2 goes into itself once, 2 goes into 10 5 times, 5 goes into 15 3 times, 5 goes into 10 twice. If you've reduced the fraction and you still have a fraction, you need to fall bottoms up. 5x minus 1 to x plus 3. Now we didn't really just have this big X or a star as I normally had it up above. Really that was in place of x minus 1. So now I'm going to rewrite it as 5x minus 1 and 2 x minus 1 plus 3. So I've replaced this x with what it was. It was x minus 1. There's no need in my class for you to distribute and combine like terms. This is fine just the way it is. Please write down example 2, press pause, and then come back to the video when you're ready. 8, 2, and 3. Is there a number I can divide over all of these? There's not. So I'm going to rewrite this as 8x squared plus 2x minus 3. 8 times negative 3 is negative 24. What 2 numbers combine to give you a positive 2 but multiply to give you a negative 24? 1 and 24, no. 2 and 12, nope. 3 and 8, no, I'm getting closer. 4 and 6 work. It needs to be a positive 6 and a negative 4 to multiply and to combine accordingly. So I have x minus 4 and x plus 6. Now the leading coefficient is not a 1, so it must go underneath. And now I'm going to combine, or sorry, I'm going to reduce those fractions. 1/2 and 3 divided by 4. Okay, both even, so 3/4. Now, I didn't have an x. Actually, x was x plus 2. But before I do that, I almost forgot to do bottoms up. I had fractions that were reduced, so I needed to do bottoms up. So it is 2x minus 1 and 4x plus 3. Now, really, what is this x? It represents this x plus 2. So 2, and not an x plus 2 minus 1. And 4, not x plus 2 plus 3. Writing down example number 3. Press pause if you need to. 6, 7, and 10. There's not a number other than 1 that I can divide out. So I'm making this as 6x squared plus 7x minus 10. What multiplies to give us 60, negative 60, and combines to give you a positive 7. Let's do this together. We have 60, no. 30, no. Getting closer, nope. 5 and 12 work. 5 and 12 work. Now, it has to be a negative 60, but a positive 7. Negative 5, positive 12. So I have x minus 5 and x plus 12. I'm making the x extra large to represent that it's really representing this area here of x subtract 4. And now I'm going to take that leading coefficient, since it's different than 1, and put it on the bottom. Reduce those fractions if possible. When it reduces to a single number, you don't have to worry about bottoms up, but if it doesn't, the bottom number goes up. So 6x minus 5 and x plus 2. Now really, what was at x? It was an x subtract 4. This problem, again, we're looking at an 8, a 6, and a 20. Oh, okay, well, I can divide something out here. Look at the smallest number, which is 6. I'm going to come off 6. What breaks into 6? 6, 3, 2, and 1. They don't all divide by 6. They don't all divide by 3, but they do all divide by 2. Not only that, I have 3 groups of x minus 3, 2 groups of x minus 3, and 1 group. The most I can take out of each term is 1 group of x subtract 3. So what would I be left with? I'd be left with 8. Now there's 2 groups left because I just took 1 out. So x minus 3 quantity squared. Oh, I don't want an 8. 2 times 4 is 8. 2 times 3 is 6. I need 2 groups. I have 1 out there. 2 times negative 10 is negative 20. I need 1 group, and I already have it. I'm going to rewrite this portion just to make it easier. 4x plus 3x minus 10. Okay, let's look at this trinomial. Multiplies to give us negative 40, combines to give us positive 3. 1 and 40, no. 2 and 20, no. 3 doesn't divide into something to give you a nice 40. 4 and 10, no, but we're getting closer. 5 and 8 work. Now I need a negative 40, so one of these has to be negative, and I need a positive 3, so plus 8 and minus 5. Plus 8 minus 5. X minus 5, x plus 8. Okay. Remember, the leading coefficient is not 1, so we're going to put a 4 in the bottom. Can't be reduced. This does reduce. Now, if it's a single number, you're good, but if it's not, we got to do the bottoms up. So 4 pushes up. I have 4x minus 5 and x plus 2. There's a couple things we need to go back and do here. Remember, we really don't have an x. X really is 4. It's x minus 3 is what this big X represents. And x minus 3. And don't forget about what we took out originally, which is 2 times x minus 3.